Assalamualaikum and good afternoon. I bid to Chief of UTP's Civil and Environmental Engineering Department, Associate Professor Dr. Bashar S. Mohammed, respected lecturers, students, and members of UTP Civil and Environmental Engineering Student Society, UCT, as well as the members from Institution of Civil Engineers Student Chapter, ICESE. Welcome to the Civil Week Forum and Quiz. My name is Muhammad Nur Salam bin Sabaruddin, and I will be the MC for today. On behalf of UCT and ICESE, we appreciate you taking time off your busy schedules to attend this session today. We hope you will find today's program to be engaging and beneficial for your future. Today's forum is one of our planning activities for this Civil Week. For your information, Civil Week is a program conducted annually by UCT and ICESE. Civil Week is a program conducted annually by UCT and UTP Civil and Environmental Engineering Department to allow the students to expand their knowledge and highlight their talents and love towards civil engineering. This year, we brought you a different experience. It is the first time UCT is collaborating with the Institution of Civil Engineers Student Chapter, ICESE. Started with our opening on the 28th of February 2021, this forum is the second activity conducted for this event. We are now ready to begin the proceedings of today's forum. I will pass our next session to the moderator, Muhammad Arif bin Muhammad Sabri.
Thank you to the MC, Muhammad Nur Salam. Before we start, I will describe a bit about our speaker, IRS Gandhi Supia. IRS Gandhi graduated with his Bachelor's Engineering with first class in Civil Engineering at the University of East London in 1995. Then, he graduated with his Master of Science in Engineering and Computing at Oxford Brookes University in 2002. Later, IR Gandhi graduated with his Master of Business Administration at Durham University in 2017. He is currently a fellow member of the Institution of Civil Engineers, a member of Chartered Management Institute, and a Chartered Manager in the Board of Engineers Malaysia Professional Engineer. He also specializes in asset management, bridge design, and maintenance. Now, I would like to invite our first speaker, IRS Gandhi Supia, will be presenting about the modular construction and manufacturing in IBS. Without further ado, please welcome.
Thank you, No Salam. Can you hear me okay?
Yes.
Yes, sir.
Clear.
Yeah, that's good. So hopefully there's not an echo. I'm in a meeting room on my own in my Menara UEM in Bangsa South, and very few people at work. This is the new normal at this moment, how things are. So let me go through, project my presentation. Give me a second. Can you see this?
Yes.
I'll put it into play mode. Okay. First of all, I think congratulations to UTP. Since your launch, you guys have been active. Well done in getting this organized, having a civil work. It's fantastic to see UTP, embracing the IC student chapter and progressing with your civil work and getting things done. And by all means, do shout. And also, I'll say thank you now to Kung Wei itself to want to invite me and to the committee, but also, being proactive. So the topic in question is modular construction and manufacturing industrial building system. So IBS in this case, and IBS is a very Malaysian known concept in the sense in terms of the terminology, but I'll come to that in a while. So these are the contents. I think you may have seen the contents been given by Kung Wei earlier. So what is IBS, or offsite or modular as such? if you look at that on the top of your screen on the left-hand side, that's the Parthenon in Greece. That's you can see the Oxford University arch in the center. You can see Eiffel Tower at the top right hand, and at the bottom a sort of castle in Wales built in 1283, while the Oxford University was built somewhere in the I think in the 16th century as such, if I'm not mistaken. This building, the Parthenon, is over 2,500 years old, while Eiffel Tower was built in 1887, if I'm not mistaken. So, what is similar of in the construction of all this throughout the ages, from going back from 2,500 years to present. All of the buildings or infrastructure you see here have got elements of modular construction, or what you call industrial building systems. And so this is nothing new. This has been going on for over 2,000 years. So what we're going to talk about is in terms of modular and IBS and offsite as such throughout these slides is conceptual thinking that's been designed and implemented, executed, and maintained for quite some time now. Now, just talk about a little bit of concrete prefabrication. This is Thomas Edison. I'm sure everybody knows about him. Famous inventor, electricity, communication, railroad, and you can think of anything. But Thomas Edison also was involved in looking at prefabrication of concrete homes in the 1970s, and already thinking, how do I put and quickly scale up homes for people? And this is, during and post-war as such, after the First World War. And I'll come to that bit about war and how this is a period of time that actually pushes prefabrication or modular. This is in 1967. And, look at the flexibility, look at the way that's been constructed. These are all 158 concrete modules. It was built for a World Expo. It looks fantastic, facing the sea, amazing looking structures, things that you don't see at this moment in time, surprisingly, but done in 1967 and full modules. But we are coming to that renaissance again, and we're coming back to this age of constructing back to modular construction. What about this? I'm sure all of you, many of you grew up playing with Lego. So Lego has got a modular building collection. They have this, the newest one is this police station. So when you look at Lego and think about modular construction, the basis is there. In fact, Lego, people like IKEA in Scandinavian countries as such were involved in some element of modular construction in the early years. But this is great, and it's this set is not for the young age; it's for 16 plus. So we all still can enjoy playing with this Lego set if you really wanted to. It's quite a challenge to put it together. So I'm showing you about industrial revolutions and what has industrial revolutions got to do with modular construction. So the Industrial Revolution 1.0, in the 1780s as such, was in the advent of steam, with a steam-powered system coming in place, and mechanization, and weaving looms being invented as such. That is, assembly lines to some extent coming into play. This represented a change in the way that things are developed, put together, fabricated. So during this period of time itself, there was, quite a lot of modular thinking already. But in terms of putting together and fast scaling up assembly lines, this was a big part. But it was the start of technology in many ways. And when Industry 2.0 came along, which was electricity, this was during the time of Edison, and during the time where steam really scaled up also, and mass production was beginning to become a big part of the civilization as such. Prefabrication or modular design was a big thinking part, a big thought. And during this period, of course, the world went through a major transformation with the, unfortunately due to World War I, and after that through a major global financial crisis in the 1929, such 1930. So when that happened during that period of time, there were so many modular buildings that had been designed and constructed post World War I to house people and those who were displaced and so on across the world. In the US, it was a major thing. So Industry 2.0 did bring modular construction right to the front as such, and it was a big part of where we are now in terms of modular thinking. 3.0 came, quite a bit away as such, from 1870, nearly 100 years later. But during that period of time, there was World War II in the 1940s, as you know. And once, when the war was over, modular construction really did pick up. It was probably the biggest thing that happened in terms of modularity post-war. The biggest development in terms of thinking, the UK with the amount of destruction in Europe and US, and even Japan as such, modular construction became the biggest buzzword, the biggest thinking as such to get homes completed fast, rebuilding communities and getting civilization back on its feet. And 3.0 came along at a point where computers and electronics became mainstream. At this point, they were talking about industrial buildings as such and how to quickly assemble buildings to cope with the automation that was happening around the world. And you can see, Steve Jobs, Steve Wozniacki at this point in time made big news with the computers and automation as such. That was where the revolution started. In the sense and where we are now, which we are in Industry 4.0. Now we are in the cyberspace, in the systems thinking, Internet of Things, networks, as such, digital age, Industry 4.0. In the sense, we are now scaling up prefabrication more than ever. There was a period of time between 1969 to today, prefabrication or modular thinking was not thought of, wasn't popular simply because people didn't want to live in the same sort of type of houses and same development as such, and therefore it dropped off in the sort of 80s, 90s, and people weren't thinking about modular construction. But now in the 2000s, it's back in the frame, and that's what we're going to go through mainly. So industrial building systems, or IBS, it's a term used in Malaysia. If you look up in Wikipedia, you'll find that it's a technique for the construction where components are manufactured in a controlled environment. Now, remember the word controlled environment because whether it's offsite or onsite or placed in or assembled, construction works as such. So industrial building system concept is actually modularity, but in a more talking about components in this case as such. So, but in worldwide, IBS is known more so of prefabricated or prefab construction, if you can say, and in some sense now what they call MMC, modern method of construction, and also offsite construction. So all of these are coined together with the modern setting of what they call modular construction. So, which is what I will more focus on in here about the modularity. So IBS, modular, so on. It's a very simple concept, nothing difficult about it. It's really have an architect draw up the plans, put it into a setting that you can think about using prefabricated or components that can be manufactured together. Go through look at how many components you need, what type of components as such, how to scale up, how to have this in the manufacturing context as such, and then start building it. So you just start building it, put it on the back of a truck, take it to site, use a crane, and lift it in place. That's as simple as that. Nothing too complex about it, in the sense that what it does is it streamlines construction process, streamlines thinking, and able to do things faster compared to we still building formwork and pouring into formwork on site, and with the amount of wastage and the use of extensive foreign labor as such. So IBS was thought about in Malaysia, was thought about from that perspective of how to have better quality, better safety, less wastage as such. But in Malaysia, it still hasn't really taken off. It's not become a big concept, although I was privileged to work with Dr. Kim Elliott in the early 2011, and I was one of the working committees for construction research about CREAM in Malaysia, where I contributed to the specification for IBS. So you can find it on the internet and you can download it. It's a specification, but there's things that I think you will pick up and good for research at this point in time. So types of industrial building systems. So this is what's classified as the 5 main groups that are used in Malaysia. Precast concrete framing, panels, and box systems. So we'll have a look at one of those in a while. And steel formwork systems. So steel formworks that are that you can cast your in situ slab between concrete elements. It could be in situ concrete beams, or it could be a precast concrete beam. So you have like a bond deck type steel formwork system, which has steel studs in it, and you place reinforcement and just pour concrete on it. Or steel framing system, which we'll look at that in a bit. Prefabricated timber framing, not very popular in Malaysia, particularly with the ants and termites and so on. So it's not widely known in Malaysia, but it's widely done in Northern Europe, Northern US, even in the UK as such. And blockwork, of course, as you know, bricks and mortar is still a big component part of IBS. And you saw the castle built in Wales in 1283 was all stones and masonry type, and that is considered IBS. So precast concrete components, as you can see, this is a fully precast columns with hollow core slab with precast beams. So it's really rapid construction doing this, even with concrete wall panels. You do foundation as traditional with pile foundation. You have the pile cap with rebar coming out, and you can slot in your column into the pile cap and straight away grout it, and off you go. And it's proven quite fast. Quality is really good. All manufactured on site. In a factory. And they've used this extensively for schools, hospitals, various in government systems, government buildings, but it still hasn't get popularity. Simply, there's limited players in the market. The setup is quite expensive for anybody else to get into it, so it hasn't really taken off. But then this is, compared to what we call, and what we'll talk about in a while about modular construction, this is going back still behind time in terms of modern or advanced technology in construction. And what about this? A completely prefabricated school in the US. This is a steel frame with concrete elements built into it. This was completely prefabricated and put in place. Other than finishing inside, this you can't see any difference to a normal construction as such. Even the front is all paneled and installed in place. So these are single-story building, easy to construct, very quick, was done within a couple of weeks, other than the finishing that needed to be done following the installation on site. Now, you look at this, the one on the left-hand side is a timber, completely modular construction, using just timber that's been latticed together and balanced very well with a lot of structural thinking behind it. And while the image on your right-hand side, that's the Shanghai Expo inverted pyramid constructed using hollow steel, massive steel tubes that's been constructed offsite, brought together, bolted in place. So modular construction, or IBS in this case, can come up in various different ways, various different looks as such. But what you need to realize is the speed of construction here and the number of people that were used here was lower compared to any standard buildings. Particularly the Shanghai Expo, this building is quite significant, so 20 stories in height. And it's an inverted pyramid with a lot of structural thinking, with a steel core holding this in place with piles, I think board piles as part of the foundation element to it. Timber composite, so as I mentioned, we don't use it that much, but construction using either pure timber or timber construction, using with concrete floors as such, that could be done either for internal floors or even for roof or walls as such. So this gives quite a bit of rigidity to the building, but also durability built into it, and they could be made into panels, as you can see, offsite and lifted into position. And very quickly you can get the construction, get through the other trades in there, like electricity, plumbing, and so on, can be done really quickly, because you're talking about timber wall panels as such that you could drill in. You can direct your electric cables, or even pre-drill, decide where you want to go. And this is an extremely fast form of construction that is used in mainly in European countries, and that comes with, as you can see, insulation built into the wall as such and in the roof. So it all comes together as a single component that then gets erected. So I was working in South America, in the Falkland Islands, for about a couple of years, and I shipped in 20 containers of houses on the similar sort of concept, where each container contained one house, 3-bedroom or 2 bedrooms, and all we did was, it's like Lego. The gangs, each house had a gang of 3 people, and they were able to get the components out and fit the house together with very minimum fixing requirements in terms of nail. I mean, yes, some screws, but they were all Lego. They had their own sort of wood pegs requirements in place, and each house was in under a week. So, and that was really, really fast. The foundation took longer than the house itself. Then the one that took the longest, of course, is getting the plastering work done inside and getting all the other trades, the electricity, the plumbing, and the heating, and so on and so forth. So it's a very well-known concept in Europe and parts of even South America now. So I've been talking about modular. So why modular? Let me come off my video. I think it's slowing some things down here. So why modular? As you can see, standards, it's very precise engineering in a very manufactured environment that delivers consistent standards. You can have the repeatable, it's in an environment, in a good setup as such. Doesn't matter how varied it is, what type of construction standard, whether it's BS 8110, EC European codes or ACI in this case, American standards as such. It doesn't matter. You can engineer this in a very controlled environment. The cost of putting or constructing this on site is really, really low. And building this fast as such compared to traditional construction, where you can have delays from either material damage or variability as such, and variability in a lot of the buildings come from foundations, but then when you do in situ construction, you can end up with quite a bit of variability, and you could end up with various defects that could develop over time, over the life cycle of the building due to the variability. So modular construction in life cycle term is cheaper, but what is not so cheap is setting it up initially to get the modular construction in place. From a time point of view, offsite is fast. It's as I'll show you in a while. You can simultaneously progress, write your different trades, disciplines as such, while you're preparing to do the offsite construction, compared to traditional construction, which is very staged, and you cannot, many things can't come in place until many of the framework is all done and dusted before you can have trades coming into play. Profit-wise, as you can see, shorter bill means it's cheaper. Investors who are invested can get their return of investment quicker. You are also not, less exposure to market changes as such, and that in unpredictable times like now, particularly with the coronavirus, the pandemic having a great effect on the progress of construction. Offsite construction will rapidly speed up construction, enable things on site quicker as such, and investors then having less risk and getting their return back quicker in an ever-changing market condition. So what I meant about modular construction time savings. So when you look at it, the two traditional construction and which is site built in this case, and modular construction, it's pretty similar with the design, engineering, permits, approvals, and so on, until it comes to the site development stage in modular, where you can get your plant constructing your components as such, off-site, in a controlled environment. And it's once after this, when the building construction starts on site, the traditional construction is going to take you longer, and I'll tell you how long it's going to take in the next slide. But when you look at that install and site restoration as such, it is significantly faster than the traditional building, and there's a significant time saving. So this is a recent article that's come out from McKinsey that shows that, when you compare a 24-month construction period, traditional versus off-site as such, or modularity in place, then you can be between 20 to 50% faster. You could finish what might take you 24 months in 12 months. Now that's incredible. That means, as a investor, you are getting a returns faster. As a person who's bought a property as such, you can move in faster. You can see that how what benefits that you can gain out of this when it comes to particularly 3D volumetric construction using a modular construction technique. So, where is the modular construction going now? Where is the direction of modular construction in this current space in time? And with the Industrial Revolution 4.0 in the last few years, building information modeling becoming more and more popular. I mean, I know that we are still in the adoption phase in Malaysia, not used as widely as it should be used compared to some of our neighbors and some parts around the world. I mean, for argument's sake, in the UK, construction of BIM in construction industry is as high as 80%. As such, in Malaysia, we are still lagging somewhere between 15 to 20% depending on the type of construction, and we have actually done more BIM in the linear construction, that is highway construction at this moment, than actual buildings, although it is gaining high traction as such. And if you look at the image on the bottom right hand corner, you can see that that's actually a augmented reality setup where or even in your virtual reality space, where you can see where the modular construction elements are, how you position your ME, mechanical, electrical, plumbing devices as such, and how to avoid clashes. And you can do clash analysis, of course, using sort of tools like Revit. You can eliminate all these issues that you face on the site later on when you come and install your MEP, and you find that some in situ construction, they have put a column in the wrong place, they've put additional beams, or they got additional walls they've built, and all the MEP you've thought about in the design phase will have to change on site due to the fact that the lack of communication. And so BIM works fantastic in modular construction to eliminate a lot of the site errors, but also in terms of BIM on the whole, for everyone here, also means you can have a collaborative framework to work together to quicken your construction and have more preciseness and efficiency. So this is a BIM module for it's a unit workflow using Autodesk, where you can look at all your modular components, you can segmentize it, you can look at how the modular elements are all tagged. Each one of them have got their own specific identification, and that they can be put together in a virtual space, constructed virtually before you go on site. And so one of the things that what BIM combined with modular construction does is, you look at the survey done is, many thinking said that what sort of period of time that modular construction combined with BIM can reduce time, and it decreases by 4 weeks or more. But in most cases, you look at it, you're in the about 2 to 3 weeks. Has the two combined survey together shows that that's where it's going to be more effective. But what also it shows is the project budget, the decrease in project budget. Now, this is a bit of a controversial thing in particularly this part of the world, because for engineers and architects, the project budget dictates their fee. So pushing out modular construction and using advanced technology has not been popular, because it can have, in effect, reduce your fees. But I think we need to change that mindset, that thinking as such about how engineers bring value using technology as such, and using modularity in place as a modern method of construction, and therefore they should be paid accordingly, not based on project budgets, and rethinking has to be done. So this is something that I think that's coming in more and more into clients' thinking. So it's about educating the client as such on how we approach when we do BIM and modular workflows as such to deliver a more efficient, faster job, where the client then can also mean that they finish the job at a higher quality and faster, and can move on to the next job. BIM also in modular design as such, can be used for site layout planning. As you can see from here, you can plan how your lifts are going to be, how you want to position your crane, where you want to position your crane, how you're going to lift components, where how you decide on a lifting plan, and how you sequence your stacking as such. And this is all done virtually now. This is quite standard practice nowadays in modular construction. If you look, I'll come to you some of the modular construction jobs, and I'll show you that they have used this planning in place for going up to 4D to 5D sequencing as such to ensure that they can plan it, sequence it, and measure it, and ensure that safety is part and parcel of this, and cost is measured carefully, and everybody knows what need to do. So this is a very collaborative framework, and these are the advanced construction methods now that have been used. As I said, Malaysia really is getting in there, but it needs to do more of this. But those in university now, it'll be worthwhile for you to learn this, because with the future plans in Malaysia to build 100,000 homes, and Singapore looking to have major construction in place over the next few years for various modular buildings as such, and so on in the rest of the region, understanding this concept and knowing how to use this concept would be a great asset. Now, I mentioned earlier about steel framework. I think if you look at this, steel framework with the Eiffel Tower in 1887 and been constructed, all manufactured off-site. All of the Eiffel Tower component was manufactured completely off-site and brought in there and riveted. So when you look at a steel building like this, nearly all the steel framework is everything off-site, and then it's brought into place and put together. Now, this is one of the best forms of modular construction as such, or I would say more on the industrial scale, not quite fully modularity, but able to be put together extremely quickly. And there are now wall panels that are all completely prefabricated offsite for the steel framework. There's very, very little that ever gets done on site other than the MEP. Even the MEPs are fully prefabricated, and they come and joined together in major steel buildings like this. The building that used to take maybe 18 months for steel framework is 50% faster easily, and the number of people that work on such jobs nowadays is about 30% compared to what it used to be on a steel framework building. And there's not enough that is being done in this space as such in Malaysia at this point in time. Simply there's a lot of industries that are opening up, but then with the new data centers that they're talking about and new requirements for various different industries that are coming up, the modular construction with steel framework will come back, and it will. I think that in the next 2 to 5 years, this will be one of the major areas that will be pushing back up as such in the industry. Now, I'm sure all of you all know about Gamuda and Gamuda's facility. That's nearby, not far away from KLIA. When you take off, you can see this facility sometimes from the air. And this is Gamuda's facility that's been built to do IBS. So they're talking about a controlled environment that's looking at either doing here, you can see the wall panel as such, and construction to high quality as such. So Gamuda is one of the leading proponents of IBS in Malaysia. Or more so modular construction, because they're talking about wall panels, not just talking about individual components, but rather a volumetric construction compared to some of the different manufacturers who are doing just column beams, hollow slabs, and so on. So I think it would be a good idea to look at trying to see, once the MCO is over and things are back to normal, organize a site visit to Gamuda's manufacturing facility, because it's a great place to go and learn quite a lot about how modular construction is done in a very controlled environment. Now, I'll talk about a little bit about what's happening in the modular construction. You can see on the right-hand side a whole unit been lifted in place as such. This is not off-site yet, but this is modular, right? And this is the tallest building in Europe at this moment in South London. It's 44 stories. One is 44, the other one 38 stories. It was constructed in 35 weeks. That is an amazing speed in construction to complete this job. It's 50% faster than any traditional. The cost saving was phenomenal in this. The number of people that worked on this job was half what was required, and it was one of the safest jobs to put in place, and it was high quality, very quick, precision job, and completely designed using BIM technology, BIM using Revit and Autodesk systems. However, I'm not sure if anyone, if you want to shout out, you can shout out. I don't know if you know where this building is. It's the tallest building in the world at this point in time. Anybody knows where this is? Or want to guess? No? This is in Singapore. This is been built by Dragaj and Bui. And this is 56-story building completed in Singapore, designed using BIM again and virtual design and construction sequencing with complete lift plans in place. And it's revolutionizing, this part of the world. And Singapore's leading this, and they are going for quite a lot more modular construction. This is about 1,700 units combined in this modular building, and they are talking about building another 46,000 in Singapore over the course of the next 5 to 10 years, and most of them is going to be modular construction. So you can see that where and who is leading this at this point in time in this part of the world. So there's significant opportunities as such, and but part of it is they are looking at reducing the reliance on foreign labor, and that's why Singapore is doing what they're doing, but also fast-paced, cheaper, but safer. Now, this is the tallest modular hotel in New York. It was just constructed in 90 days. Now, you can see it's fully furnished, completed with beddings, toiletries, everything, complete. This is a modular high-rise, and it should have been called offsite, but it's called modular. Now, I'll say what's offsite a bit later, but this is with a steel box, framed, built all together, and you can see it's it's just lifted in place, fixed in place, and they kept going 90 days to construct a 25-story hotel. That's 25 or 34-story, I can't remember. 34-story hotel. It's unbelievable, really. I mean, the scale and the speed of such construction is mind-boggling now. Now I come to something that is closer to me as such, and I'm a bridge engineer, but I've been involved in modular construction or IBS or precast systems for quite a long time in my career. Also started my career in a factory, if you want to say, as a bridge engineer on a short line precasting facility, where we did box girders for a bridge across the Tagus River in Portugal. And so I'm not sure how many have watched the top left-hand corner, the video for the construction of this bridge, which was constructed in 2 days, or was put together in 2 days on the abutments, on the bearings. It was constructed completely offline, and it was wheeled in place by over 440-odd wheeled vehicle over 2 days with a 2-day road closure, and it sat into its bearings, and the road was subsequently opened. This was for the high-speed 2 construction, which is happening in the UK at this point in time. This is close to Solihull, and it's a very modern method of construction at breakneck speed. The other two jobs here you're talking about, one is in the middle, in the lower part, is a full-span launching method over the Incheon Bridge in South Korea, where full-span segments are are brought in by sort of transporters that are travel on the bridge, and they get lifted by what they call a launching gantry with a super beam, and they are put in place one after the other onto the crossings. So this is at a fantastic speed. All this happens, and construction is very, very rapid on a bridge that are kilometers after kilometers, 15, 16 kilometers, and very, very fast over several weeks, and the bridge is in place. But there are a lot of other variations, other innovations where bridges could be constructed with purely beam and slab, with an in-situ slab or beam, or you can see the components that it could be precast piers, precast box piers in this case, or pier caps, even casting. Even the footing sometimes can be precast, but in this case, in most cases, it will be cast in place footing. But this is high quality precision work that is all done in a factory environment, or even could be an outdoor environment, but with a control that is required to steam cure it to achieve the same desired quality of an indoor environment to some extent, and then brought into place inside and placed in quickly. Now, the next evolution that we are talking about is the modern method of construction, is the offsite manufacturing. You can see what, the Marriott Hotel in New York is very similar to the offsite manufacturing, but the reason it wasn't classified rather in the modulars, there's a variety of different components and different elements of construction that meant that they didn't fully classify it as, say, offsite manufacturing. Here, the whole components are manufactured completely again, offsite, and just come and stacked in place. You could have shipping containers to do this, and there's a variety of homes that are now built with shipping containers as part of sustainability, or you can say a circular economy, or shipping containers that are not being used that could be used to construct homes, classrooms, different buildings. The speed of production is is even faster than modular construction. It is cheaper to do to some extent when you're using steel framework. You don't need to do major setup compared to a concrete framed modular building or even offsite. Because concrete particularly could be quite heavy to lift, while steel is faster and quicker to do such things. It's validated, it's tested on site, off-site first before it comes and installed, so everything is checked out. Safer, very few labor is required to do such things. Completely done classrooms can come in place, or as you can see, hotels, hospitals even, can come completely manufactured off-site and then come and put in place and could be there within 2, 3, 4 months. But one of the things is, it needs repetitive work. It might not look pretty. It's going to be a box standard. Architecturally, very little is required, other than it's going to look a very standard looking building. There is not much beautification, although it can be done. But again, you're increasing construction and you're doing things on site that you don't really want to, if you can help it. So it's really rather plug and play. But it needs also front-end investment, so you need to have contractors, stakeholders, people buying into this. But one of the biggest limitations is also limitation in transport. How wide, what sort of design needs to suit a transporter as such, needs to suit width of the highway, the road that it's going to come from. So there are some limitations in that respect. So the next evolution in this, of course, is 3D printing, additive manufacturing as such, where you are talking about robotic arms or a gantry crane type system, which is printing using, it could use sustainable material that could go into it, like rice husk combined with cement additive. So it has a sustainability element that could be built into it, and it is very fast. You can have a home constructed within days when you use such systems as such. And Malaysia has and is considering manufacturing, but then we need to tackle the modular construction first before we jump into the additive manufacturing. But then I think we should look at doing some trials in the future and see how fast we can build in rural areas and get housings done for people who are in desperate need of good homes. And this is just a image of a 3D manufactured using additive manufacturing or 3D printing. It's a virtual model that looks at how it will be done and how even the roof components can be put in place using different cranes as such. So it's a game changer. It is going to happen very fast, and all you're talking about is about 2 to 3 people on site, and you can have homes done, and you can have homes that are going to look different. You don't need to have that repeatable look from off-site manufacturing. You can have architecturally looking homes with 3D printing. So what's the future demand for modular construction? All right, I mean, you look at that modular or off-site, or the complexity of this as such, and the increasing scale of the different type of components is now being driven by the cost of labor going up, but also the amount of foreign labor that you don't want to be bringing into the country as such, and the shortages that are happening because of that. So the biggest traction that is getting in Australia is really big into modular construction. So it's UK, Singapore, I showed the building earlier, US in the West Coast. So it is a sort of modern method of construction, or it is a demand that has been driven, and it's growing faster than any other form of construction at this point in time for buildings and housing. And if you look at it, the future market size is phenomenal. Over the between now and 2025, as you're talking about a market that could be up to $108 billion worth. That's absolutely phenomenal, and 47% of this modular construction is going to be in Asia. So from a perspective of you engineering students, I would look at this. I would look at to see how this could be also be taught in universities in terms of how technology can play a big part into it, like using BIM workflows, how modular construction, additive manufacturing, modern method of construction or offsite as such, what is required, what sort of workflow is required, how is it componentized, how is it put together as such. And very few universities teach this, unfortunately, but I think there's a possibility that such things can be developed as part of a course structure for universities in Malaysia, as this will be required to drive the thinking behind this in Malaysia. And finally, I want to just go through future material development. I've got probably about another 5 or 4 minutes in this. When you look at future material development, and these are future development of materials that will be built into the modular construction area, and I'm particularly talking about concrete here, ultra high performance concrete as such, typically you will learn the university, you'll talk about grade 30, 40, maybe 50, but I'm talking about grade 80 to 150 as such. When you do such high grade concrete, you can slimline or make your components thinner with similar sort of strength, but you have to tackle the durability issues or brittle issues as such. But it can be tackled. I mean, I've got a bridge that I'm working on at this point in time, which is using grade 110, and KL 118 is also using somewhere in the grade 120 or 130. For their concrete to make components, their core walls thinner as such. The other, the next one is light transmitting or meeting concrete. Now we are developing concrete that is able to absorb lights and able to emit the light during the nighttime. So they're light up. It's like built in with bioluminescence that is able to extract the sunlight over the daytime. So you can have sort of on the highway, lighting up the sort of where you have white lines, instead you have concrete paths that are being lit up using the light transmitting concrete. You can have signboards that are having light transmitting concrete, or you can talk about architecturally on the faces of building. All this can be done. I'm also talking about something called graphic concrete, where modular construction particularly, you can have concrete that is able to match any type of sort of shape that you want with a particular form in your constructing your modular unit that is able to give architectural dimension to it. And some of the other concrete products or innovation cement is self-healing cement using bacteria to help reduce incidence of crack, and that where crystal will develop in formation of crystals will develop as the concrete cracks. Concrete is a material that is going to crack. It's an inherent part of the concrete as such. So to remove some of the unsightliness of concrete as such, you can have self-healing concrete where the bacteria will close the crack, and therefore you don't see any cracks in the buildings. Graphene reinforced concrete, it's a nanotube, and you can put the nanotube into the concrete, don't need to have reinforcement built into the concrete. So this reinforces the concrete and gives this inherent strength. 3D printing, I've talked about. Recycled material concrete, having demolishing and reconstructing buildings and putting recycled concrete, it must be a big part of sustainability and should be a big agenda in terms of how we tackle the climate change and carbon emissions. And that's one of the key components of modular constructions also. But in a competitive solution, coming up with competitive systems, you need to have this digital environment as such, using a 3D environment, using either BIM and virtual augmented reality. And this digital platform should be built together as a partnership with the stakeholders and them knowing what are the benefits of putting the sort of digital solutions in place for them. And this should be done with new types of contracting models that we believe that can, deliver better solutions for implementing modular systems in place. So that finishes off my presentation. Hopefully, that's given you a good flavor of what modular construction is about, whether it's IBS, offsite, and various requirements as such to have it in place. Ultimately, it's not new. It's been there for such a long time, over 2,000 years, and this has been going on. But we are in the next renaissance of modular construction, so I think this has taken off big time, and it will be a big part of the future for all civil engineers around the world. Thank you for allowing me to speak, and I will come off the presentation now. Back to the MC.
thank you to IRS Gandhi Supia for spending time with us today.
Any questions, let me know.
Next, we would like to open the floor for inquiries, if any. Is there any question?
Don't be shy.
I have a question, if I can. Hello?
Hello?
Can I raise
Any
a question? Yeah. My name is Dimas. IR Gandhi. I'm staff, academic staff in civil engineering. When after you presented the development of the materials or technology in construction following the IR 4.0. What is how do we strategize with our research? That means that what is the most important agenda or most important direction in research and development to how do you say it, to meet with the IR 4.0? Thanks.
Yeah, I mean, IR 4.0 is about one, Internet of Things, sensors as such, and using better workflow in the context of modular construction. Let's say the using the Internet of Things, using the modern workflows as such, is definitely going to help you come up with better construction techniques for modular construction as such, because you also then can have a better life cycle of in your modular construction. You can monitor your building. You can talk about how you can build in sensors into your building from the offset itself in your production areas. And you can monitor them. So you can have actually smart cities, smart homes with a modular construction technique better than what you do with the in situ construction. So because the higher quality, the communication systems can be delivered. But from a perspective of the advent of 4.0 from a digital environment, automation, mechanization, it's a bigger component of it also. So the modular construction allows this setup, the factories that can be mechanized and can be completely automated to build the modular construction units. And you can have virtually like an IKEA system, which they have in Scandinavia, where a complete componentized, put together or in a Lego fashion and delivered on site, and with very little involvement in sort of people involved along the way, other than in the front end where you need engineers, architects still, and then the back end you need contractors to install this. So that's part of the mechanization, automation part of IR 4.0, I would say. I hope that answered some of your questions.
For the Malaysian context, for example, what's the most required by industry now? What that we can try to catch up in the research and development?
Yeah. I mean, in the Malaysian context, we need the stakeholders, the government, really to drive this. We need their support. I think the government is trying to drive this, but we need the industrial players. Gamuda is only one, but we need more. We need people like MTD. We need ACPIs, ACPI, MTD, I think, and we need other players coming into the place. We need contractors to shift their traditional thinking into thinking how can they do this faster, cheaper, So there's got to be a societal benefit of thinking a social element to this. So for them, they have to think that, you know, if they can do this faster, they can move on to the next job, and if they have more of this, then they a return of investment as such in a different way. They don't need to employ as many foreign labor as such. They can have faster safer construction. So it is within the industry to do this, but it's again, you know, whether the industry wants to flex to this. If you look at Singapore, you know, and Singapore, let's not say it's a small island or whatever. It's about mindset. It's about thinking as such. It's about progression and advancement, critical thinking as such, wanting to do something different. So, honestly, I mean, you know, when we put the IBS specification in sort of 2011, we thought this will really take off in Malaysia, but it has still been lagging as such. And I think what we really need is the government to go and drive and say, I want all these buildings to be modular construction, and put a mandate in there that it's got to be modular construction. Then it will really, you will see a big drive and a big change.
Okay, thank you, Ayar Gandhi. Maybe the students have already had some of the questions now. Thank you.
Okay.
Okay, IR Gandhi. It is from Arina. She have a question. So the question is, what are the challenges in applying IBS in Malaysia?
Yeah, I think we partially answered just now with of the challenges as such, but the challenges are the number of players. We don't have enough sort of manufacturing players in the market as such. Two, as I mentioned, the mandate. We need mandate from government, mandate from like CIDB, who already said this is advisory, but they should make it as a mandate to say, I want these buildings to be IBS. I don't, you know, I think they have mentioned about schools and some hospitals that, but they give them the opportunity to also not do IBS. They give them the option to say you can do it in normal way or IBS as such. So the government should turn around and say, no, I only want it in IBS. I only want it in a componentized fashion, and that I want it to be constructed in either a modular or offsite or however it is. So, so the industry really needs to get together again. We look at it and think, okay, you know, particularly with COVID now, we can see that, you know, the difficulty we've had with construction and getting construction, and we had the issues of construction site facing delays due to either reliance on foreign labor or the lack of technology in that. So if the industry really looks upon itself and know that, you know, they want to solve their own problems, then they can change how they approach and how they want to change their mindset. And therefore, it's up to the industry, really, to some extent, the contracting industry, to decide that they want to do this together with the government. So really, as I mentioned, the challenges are, you know, one, we need more players in the market, more thinking into it, more willingness to deliver a better quality product with a cheaper, faster, and safer as such. And that look at where the benefits are for them in the context of not per se having a high construction cost, but a lower end construction cost, but you can have a better margin as such. So when they understand that they can deliver better margins with IBS or modular construction, I think they'll switch to it. But I think the lack of understanding and lack of education in some sense is holding us back. So these are the challenges. But when it comes to site construction and what I've seen in IBS, you know, the challenges are again in not fully following the specification, having architects or having engineers not fully thinking that they cannot do it completely with componentized, or not having building that can be completely componentized and repeatable as such. So those are that's another challenge where, the lack of understanding of what IBS actually truly is and could be not built into place, right? So that again is a thinking that needs to change. I hope that's answered your question. But I have to, as I mentioned, I think I've got a bit of a hard stop now because I've got another meeting that I have to go to in about 5 minutes.
Okay. Okay. Thank you for your answers. Okay. Because of IRS Gandhi will be leaving due to other commitments. Is it right, Doctor? Is it Doctor IRS Gandhi?
I'm not a doctor. I'm just IR Gandhi. Yeah, that's it.
Oh yeah. Sorry.
Just call Gandhi will do. Yeah.
Gandhi. Okay. Alright, so to the honorable guests, UTP civils, lecturers and staff, as well as the committee member, please open your camera for a photo session. The time now is 3:11 and we will allow until 3:13 minutes for participants and guests to turn on their cameras. In the meantime, for the media department, please be prepared for the photo session and be reminded to count from 1 to 3 before taking the photo.
Hey, Dr. Bashar, nice to see you again. Hey, you're on mute.
Sorry, sir. How are you?
Good. How are you?
I hope that COVID-19 it will be end soon, so I will meet you again in KL.
I hope so too. Yeah.
Okay.
I'd rather do this in person. Actually, doing it virtually is difficult.
Media team.
Okay, so I think everyone is ready now. The photo will be taken under the count of 3, 2, 1, smile. Okay, let's take another photo. 3, 2, 1, smile. All right, thank you everyone.
Thank you, IRS Gandhi, for being with us today.
Thank you, everyone, and stay safe and good luck with everything. And great to see this.
Thank you.
Thank you very much.
Thank you.
All right, bye.
Bye.
Okay, thank you.
So Arif,
Wana, how many students we have on YouTube?
70 plus minus.
Okay, good. So what time Prof Shah session?
Right after this.
Okay.
Arif.
Okay, should we start now?
Yes, please.
All right. So, continuing with the next speaker, we are extremely honored to welcome a lecturer from UTPs, Deputy Vice Chancellor, Associate Professor IR Dr. Muhammad Shahil Liu, with the topic Future of Engineering in the Digital Age. Professor IR Dr. Muhammad Shahil Liu is currently the Executive Deputy Vice Chancellor of Research and Innovation at University Technology Petronas. Prior to his engagement in the academia in 2009, he has spent more than 20 years after obtaining his PhD from Texas in the engineering consulting and management industry, as well as in advanced engineering research. Please welcome.
Let me have a quick video and audio check. Can you hear me?
Yes.
Yes, huh? All right.
Very clear.
Okay. Thank you very much. Thank you for this opportunity to address before the UCT students, our civil engineering, beloved civil engineering students. I would like to give my salutation to the department chair, engineer Dr. Bashar Muhammad, and all my colleagues from the civil engineering department. I am truly honored to be able to share this because this has an important implication for the students today. Now, a lot of us, especially you young adults, you must know that as of today, in the marketplace, you have people from the baby boomers. I am from the baby boomers. And we are people that is born from 1946 to 1964. You have Generation X, people who are born from 1965 to 1980. You have people in the millennial generation who are born in 1981 to 1996. You have Generation Z, people who are born in 1997 or after. And of course, Generation Alpha will be coming in for people who are born in 2010 or after, but you will not see Generation Alpha in quite a while. Perhaps in 2030, we'll see that coming to UTP. But at the moment, Generation Z would be the one that today is Generation Z. You just imagine I am actually 3 generations behind you guys now. And there are definitely a variety of challenges that you will see as far as how people interact with each other. And in the workplace today, you will see these 4 generations interacting with each other. With the exception of Tun Mahathir, he is the builders generation. So he's 1 generation behind me. So therefore, most of the builder generation are no longer here, or even if they are here, they are no longer active in that sense. But baby boomers, we are slowly fading into the scenes. But fortunately or unfortunately, these are the people who still hold significant values to the corporate world, to the world today. But at the same time, we have to be very composed in the sense that, for myself, I just want to share very quickly that it has been quite challenging, for baby boomers like myself to appeal before a young crowd like you, because from time to time I have been asked to give a talk to the young people and to get your interest. It's not as easy as it seems to be. I remember those days when I was in Texas. We were learning engineering. The closest that we get is engineering and society. We still have that today in UTP, and also law and ethics. And that's about it. We don't talk about sustainability. We don't talk about carbon footprint. There are a lot of things that we don't talk about, right? Whatever you let the engineer design, they will design for you. If you want to go to the moon, if you have enough money, we have enough material, we'll build a highway all the way to the moon. But that is how the mentality it was during my time. But things has changed significantly since then, right? The previous lecture that you have talking about the IBS and so on. Definitely in civil engineering, whether you like it or not, we are moving towards a new transformation, especially in the oil and gas. I just want to focus more on the oil and gas, but I would like to caution you that it doesn't necessarily apply to the oil and gas itself. It is its application is quite widely seen in our area of civil engineering. So this is where I want to head on to. It's about enabling digitalization. it's kind of funny. I feel funny, because as a baby boomers, I'm talking to you about digitalization. It should be you talking to me about digitalization. But fortunately for us as engineers, especially civil engineer, we adopt very quickly and very fast. When you talk about IT, we don't need IT people to be telling us precisely what we need to do. We need IT people to guide us in the programming part of it, but the algorithm will still have to come from people like ourselves. All right. I have my assistant here, Hasia. She's going to move the slide for me. Hasia, next slide, please. Hello, Hasia. This is the age of digitalization. Sometimes you have problem with the IT. What I will say is I want to talk about the 2015 oil crisis a little bit. This is where it's affecting you today, and it's also affecting a lot of people today. Yeah. And then the other one is I want to share with you very briefly why digitalization in oil and gas industry in the sense of where you think your future should be heading. Yeah. Next slide, Hasia. Now, I think as she changed the slide, I will just keep on talking. Yeah. As you can see, right, our pandemic. I as a person, I'm quite tired of listening to the fact that everybody seems to accuse COVID as a culprit in slowing down the world economy. While that is true, but we should be spending more time focus on what we can do during this pandemic time. And this is precisely where we have to relook back. As civil engineer, it's very fortunate that you are in civil engineering. People who are mechanical and in civil engineering, you do not have much issue when it comes to employment, right? If you are not too fussy about the salary, of course. But if you look at other engineering, they may have difficulty now to secure a job. The unemployment is terribly high today. I'm not going to paint a rosy picture for you. I'm going to paint a realistic picture for you so you would understand where you're coming from and where you should be heading. The government is creating funding. We at UTP, I have instructed our team to obtain some portion of financing from the government to allow us to reskill. When we talk about reskill, it's about changing people's mindset, especially people like yourself today. Change your mindset so that you have digitalization capability when you go out, and when you graduated, you know what digitalization is all about. Okay, I learned it the hard way, but I was very fortunate because I read all the time. I follow the trend, the mega trend of the world, and I see what is being moving, from the corporate. So you have some idea, you are ready for the changes that's going to take place. So this is a very important facet of your life at this point in time. If you have an opportunity to reskill or upskill yourself in the area of digitalization, you should look into that, because this is where the application is going to take place now. I make no secret in telling you that UTP, as far as research, innovation, and commercialization is concerned, last year our budget, our revenue, my KPI, for example, I'm supposed to bring in 35 million to the university. I brought in 40 plus million. How can I achieve that during pandemic? Digitalization, guys. This is where I make the most money at the moment, because when you think about digitalization, the first thing that crosses your mind, you say, oh, it's IT. No, it's not. I'm going to change your mindset on that, right? It is not. It is people who are in engineering field that's actually making the money in digitalization. So you have to be very serious about this, because things have changed for the better or for the worse, depending upon which generation you're looking at. For people like myself, engineering, drafting, we have to use our own hand to draw even a small 7, 8, 9, those digits. And then now you're talking about CAD. Later on, you're talking about autonomous in terms of your design. Now, with the drop in the oil price here, I'm sharing with you from 1990, you see the demand, right? In the OECD country. OECD country are quite stable, right? I will tell you why is they are stable. They have their act together, right? They have their act together, meaning people are more conscious on what they are doing. They are consuming power in a very moderate way. They do not lavishly waste their power. For example, classic example, UTP. We turn on the air conditioning, that's it. It's centralized. So you cannot actually control that anymore. And once you do that, you're actually consuming a lot of power for a very little populations, right? This is where we are. We are part and parcel of non-OECD country. If you look at Denmark, 50% of the power comes from wind, all right? The other 50% come from the fossil fuel, right? So this is something that we will need to take cognizance of. And despite the massive slump in oil prices, energy demand is expected to increase, especially to the non-OECD country, people like India, people like in China, people like in our region here, Thailand, Vietnam, Philippines, Malaysia, Indonesia included. These are the culprit that actually use a lot of energy. Yeah? I think we have to take cognizance of that. Next one, Asia. So as we see the slump in oil prices, you will see that there are a lot of other energy alternatives start to come in. Nuclear has always been a steady state. Nuclear has always been part of the Western world cartel business. Nobody else is allowed to have this nuclear business. Iran tried to do that. They got attacked all the time, for example. And then you have renewable. Renewable is on the uptrend. The green color, depending upon if you are colorblind or if you are not. It's a green color. It's on a rising trend, okay? Since the drop of the oil price in 2015, all right? And then you have the natural gas. Natural gas is supposed to be a clean source of fossil fuel. I think it's probably the cleanest at the moment. Coal is bad, guys. Ladies and gentlemen, I'm going to tell you, China are one of the worst culprits in using coal. Malaysia is no different. Yeah, I think some of power plants are still using coal. All right, you go to Tanjung Bin, we are using coal. You go to Lumot here, we are still using coal. Yeah, so these are very old ways of doing business, but you can see that the demand for coal has dwindled, the energy arising from that. And then the other one that we have is actually petroleum and other liquids. Those are on the increasing trend. And these are the shift in the energy sector. Next one. And as you can see from here, even though we have a shift in the energy, you see that the increasing lease operating expenditures is reduced in expenditure and capital project, although energy demand is growing. Why is that? Very simple, guys. If you do not meet the average per barrel of oil, right, the cost of per barrel of oil, then you are not going to invest more in finding new fields, right? This is the problem today. But fortunately now, I think the oil per barrel now is beyond US $60. This is good, right? This is good for everybody. In fact, if you look at US shale, for example, there's a drop in the price over the years. Offshore oil and gas has been dropped in the price, and conventional has been a drop in the price. Saudi Arabia, the largest oil producer, can produce oil for less than 10 US. They can make money for anything that's less than 10 US dollars per barrel. Right? This is the fortunate part about Saudi Arabia. But unfortunate part about them, 87% of their GDP depends on oil and gas. So you can see this is a very bad proposition for Saudi Arabia today. They have to diversify in their economy, which is why MBS are doing a lot of things to Saudi Arabia to make sure that they diversify in their economy. Brunei is doing that. They are dependent on oil and gas in a very big way. Malaysia, today we are oil and gas dependent up to a tune of 27% of our GDP. So I wouldn't say it's bad. I wouldn't say it's that good either. I think typically you want to be dependent on oil and gas to about 10%. That's about it, yeah, of your GDP. So these are some classic examples, because oil and gas are very volatile, traded in the market. It will follow the market trends. Next slide, Hasya. So as we move along, you will see that the dwindling effect from the price of the oil and gas, right? It drops from a high of 130 US dollars to 28 US dollars per barrel. Hey guys, in my lifetime, I have seen drop in oil prices 3 times. Yeah, one time when I was in Texas, it was at about 8 US dollars per barrel. I was pumping in cheap petrol. I was driving a V8, right? 5-liter engine that is a major gas guzzler, but I don't feel the pinch because oil is cheap. You are looking at that drop, and you're looking at when you translate that, you have about not much margin to play around with that. And in Malaysia, we depend a lot on offshore oil. Yeah? Offshore oil, I think we are doing quite well now. We are moving to a lot of other countries. We are doing that. In Mexico, we have 2 blocks, for example. In Gambia, we have another 2 blocks. You know, in some of the African countries, we are developing some of the field. Petronas are typically smarter because we tend not to follow the crowd, in the sense that if there is oil and gas, it doesn't mean that we will explore that, right? We must make sure that we make money out of that. So we are more conservative in our approach. So what I'm saying is, digitization, what else can you look at when the oil price drop? When the oil price drop, it means that you have to cut costs, right? Your fixed costs, you cannot change that. I have an offshore platform. I have people operating from the offshore platform. I have my business that I have to go on. I have to produce 100,000 barrels of oil per day. I have to continue to do that. That will keep on coming out from the ground, right? And as long as that coming out from the ground, you need to balance it. And the only way you can balance it, there's no other way to balance it except operating costs. When you talk about operating costs, this is where digitalization is very important now, because I'd be very honest, right? In an offshore platform, a big offshore platform, they have about 300 equipment that is producing data every second. And you know what? We don't do anything about it. Why? In the old days, when money is good, oil price is good, who cares, right? As long as you make some profit. And we made lots of profit in that sense, right? To be able to help this country, Malaysia, to move forward. You know, the government wanted 36 billion, we gave them. Petronas gave them 36 billion. They want 18 billion, we give them 18 billion. What else do they want? So I think with that, you can see oil and gas has always been a good proposition for Malaysia, right? But for how long are we going to do that? So through the years, you find that digitalization has become one of the main forestay of digital economy in terms of cutting down the operating costs. Yeah. Today, we are looking to that. I'll share some of that with you. So I just want your mindset to think. This is not IT guys' job. IT guys will recommend us what platform to use, what software to use, perhaps what program to use. But we are the one that going to tell them, oh, under this condition, condition A applies. Under this condition, condition B applies. So they will have to write the program for us. So this, let's go on. Next slide, please. Okay. Of the 2015 oil crisis, you will find that new trends have emerged, changing the energy outlook considerably. Yeah. First, you will see the rise of new hydrocarbon resources. I mean, that is where you look at unconventional. America is very smart. Yeah. They always buy oil. They keep theirs as a reserve. Anything goes wrong, they start digging the oil, and then they will push the price down. So Saudi Arabia and OPEC countries no longer controlling the world market. You guys got to remember this. There's no way they can do that anymore, like in the old days during the Yom Kippur War between the Egypt and Israel. The other one is a changing geopolitical equation. Things are changing very rapidly. Yeah, you have to admit of the fact that we are part and parcel of that changing geopolitical equations. China is coming to South China Sea. I think the Mat Salleh suddenly realized that they make a mistake by calling it South China Sea. They should call it Malaysian Sea. You know, then Malaysia can claim that it's our sea. Now we got South China Sea. China is claiming the whole sea belongs to them. This is the unfortunate part. And then the other one is you were talking about greater penetration of renewables. There are a lot of innovative ideas in renewables. And then you got new technologies and material for hydrocarbons. I think this is something that we look at. Still, we're going to look at other kind of material for pipelines, for example. And then when you talk about disrupting the energy value chain, it affects the upstream, the midstream, the downstream, and also the retail business. Petronas, if you've been to a Petronas petrol pump, I think that's a retail business. People always ask me this question, how is Petronas different? You know, Shell and Petronas on the upstream, they work together. They go to an oil field, they produce together, they make money together. The only difference is when they go into a retail business, that's where they compete with each other. Yeah, that's why you have Shell petrol pump, you have Petronas petrol pump, you got Syntium oil in Petronas, right? You got Helix in Shell, for example. So these are what I call things that will disrupt the energy value chain from upstream all the way to retail business. First, you got a shift in the global demand patterns, right? There are countries that is a steady state, for example, And then rise of electric vehicles and autonomous driving. This is a big thing. Malaysia, we have a limited capability in autonomous driving. I used to own one, but the technology on electric vehicle is not perfect at the moment. I got rid of my car. It was too costly to maintain, right? But nevertheless, this is something that you will have to live with. You don't have a choice to that. Maybe my time, I will not be able to see a full cycle of this electric vehicle, but your time you will see that. We don't have the infrastructure, but we talk in Malaysia, we talk very big about electric vehicle. I'm surprised. Where are you going to plug your vehicle if you stay in an apartment? Tell me. This is a good question that has been raised by a lot of people, right? When I come to UTP in the past, I plug in because UTP got a lot of plug all over the place, right? But at the end of the day, you go to R&R, you don't have a plug. If you have a pure electric vehicle, you run out of energy, you can't drive the car anymore. So there are challenges. Nevertheless, the world is changing. Yeah, the Western world, they are committed to that change. And of course, in terms of the operating cost, it's far more cheaper when you move on electric than on a combustion engine, right? You are talking about saving of up to 60%. Guys, that is substantial, and there are lesser moving parts when you talk about electrical components. The other one is development of other capabilities leading to possible increase in adoption of renewables. We are looking at that. Solar, I think Malaysia is looking in a very big way. In solar, we have some huge solar farm that's coming up. I think, for example, near Kampar, there are 40 megawatt. Guys, 40 megawatt can power 2 housing complex, housing development in Kuala Lumpur. That's how big the solar can power. But guess what? When the sun goes down, the solar is out. Why is it out? We do not have the capability to store energy that big, right? The battery cannot work, right? That has a limit to that. And then the other one is new utility models. This will look at smart grids. At the moment, I think everybody knows, if you don't know this, you can talk to electrical engineers, excuse me. Our power plant, Lumot power plant, Tanjung Bing power plant, Port Dickson power plant, you name it, Parker power plant and so on, they keep on generating electricity. They cannot stop. They have to oversupply by about 20%. Right? That's why Malaysia is good. We do not have power breakdown that often. If you go to Indonesia, once in a while you experience that. Every 1 day, 2 days you experience that. Right? In Malaysia, you don't have that problem at all. Right? And this is the fortunate part. But unfortunately, the power is generating all the time, whether you are using it or not. It doesn't matter. Right? So I think with that, that's why I think hydrogen storage has been a big game plan, because the access of the power plant can give you hydrogen. That hydrogen can be stored. If you can store that, it can be converted into energy again. So there are a lot of research that has been done. UTP has been part and parcel of that. Petronas is doing that as well. So in short, there are a lot of things that is not perfect science, perfect engineering as it is. At best, it is an experimental stage. Tesla is an experimental stage, for example, and so on. So why digitalization oil and gas industry? You as an engineer, right? I will share with you, and I give you some examples, so you have some examples on how you look at things. When you have digitalization in oil and gas industry, now, because you have a smarter society, you empower the organization to do more using less. So in essence, there will be some jobs that will be lost, okay? Gone were the day you have secretaries. Secretaries are an old day school, right? During my time, secretaries are very important. Why? I come back from the site, I look at my messages, secretary take all the messages, right? Today, I don't need that. People call me on my handphone. We WhatsApp all the time, right? We talk to each other. We are very, very productive, actually, right? But there are people who's going to lose their job. Accountant, do you need accountant when you can actually program your ledger, your bookkeeping into a software that will actually do all the thing and give you a full financial report? You don't need an accountant. You need people who can interpret numbers, yes, but you don't need accountant anymore, right? Do you need a lawyer, right? People are, I know, like in UTP, we are trying to help Tabung Haji in digitalization, in coming out with artificial intelligence. Similar question that's been asked all the time, you will track those and then it gives you the answer, correct answer all the time. Okay, this is for the Hajj people, for example. And when you do that, guess what? You don't need the Ustad, yeah? Yeah, we don't need the Ustad. to be telling our pilgrims what to do next. They ask a question, the AI look into that, see which pool it fall into, and then develop that. See, as an engineer, I know the process, but if you ask me in terms of IT, I don't know. All right, I let the IT people configure that part up. So this is what it is. US power company saving money, on annual basis by using RFID. Malaysia, we tried that. River and estuary observatory network. You talk Internet of Things, environment, real-time environmental monitoring. This has also been done by civil engineer. I think in our department we are very strong in structural health monitoring. When I'm saying that, just to share with you, in a typical offshore platform, you would have a time-based inspection, meaning in 6 months, you have to do A, B, C, D. You go out and inspect A, B, C, come back and give a report. Platform is fine, good, but you spend the money, right? But in today's modern way of doing things, we use IT, we use sensors that we install on the platform. We monitor the structural behavior, we monitor the frequency of the structures, and we come back with the report and say the structure is fine, right? At any point in time, we can write the program where there's a threshold value that's been generated, right? When that threshold is not hit, we don't worry about the structure at all. What we're doing, we're actually cutting down on a physical inspection. So in other words, inspector will lose their job too, right? Yes, it is. But at the same time, we do not spend that kind of money anymore because, sensors, wire, digitalization, actually quite a cheap thing. You can buy a laptop now for 2,000, right? For example, you don't have that opportunity in the past. And then other country, they're talking about a smart toll system, smart traffic system, and then also you have automatic carbon trade-off modeler. Next slide, Hasya. And as we move forward from here, as a civil engineer, right? You say, why are you doing things differently? But let's take a look at this. Yeah, people who control the world, the mega trend by 2025 belongs to actually digitalization. Right, it's about $4 trillion US in the area, and all this, unfortunately, right? People, we talk big about oil and gas, right? Oil and gas can no longer shout they are big. They are not big. They are nothing now. If you look at Amazon, you're talking about Apple, you talk about Google. These are their asset, yeah. Their net worth of the book values for Amazon is 1 trillion. 1.6 trillion. Apple's 2.1 trillion. Google 1 trillion. Apple, when they have difficulty, the share market, they just lose 500 million, just like that. No big deal. If Petronas lose 500 million one day, they're finished. Yeah. So I think you have some ideas. This is where it's at. And look at the major oil and gas company. Of course, Aramco is the biggest today. Although they don't declare all the asset, it's valued at 126 billion. Peanuts, compared to Apple. Peanuts compared to Amazon. Petrobras, Brazil, 57 billion. Shell, 96 billion. Chevron, 159 billion. ExxonMobil, 172 billion. Petronas, 50 billion. So Aramco asset is actually in the trillions. Actually, they're about 1 to 2 trillions. They are not declaring all because they are not a listed company. You have to remember that. Petronas is not a listed company as well. Only 3 of their companies listed. Yeah, Petronas Dagangan, Petronas Gas, right, and then Petronas Chemical. So because it's listed, we know the values. You cannot run away from that. Right? There was a documentary on Aramco. You should have the opportunity in YouTube. See that. It's done by that. And then when you talk about megatrend and in relation to IR 4.0, right? You are looking at, I think the vertical scale is about degree of impact on global economy, right? And then degree of certainty as you move from low to high, from left to right. Infrastructure development is in the middle somewhere, but it has a very high impact on our economy today. Connectivity and convergence is definitely very big. Urbanization, you're talking about a smart city. If you go to KL, Sunway City, it tries to be a smart city, right? But surprisingly, right, these guys, although they are portraying themselves as a smart city, they still have their act together. They have SDG 17 goal painted all over their walls. Yeah, you don't see that anywhere else except in Sunway. So I think this is something that we as engineers, we take cognizance of. What are we addressing in the SDG, right? Goal of the 17 goal. Social trends, health, well-being, wellness, and well-being today. I give you an example, right? In UTP alone, we save about almost 3 to 4 million last year on medical expenses. How come? It's funny, right? Pandemic came, nobody goes out, nobody's getting infected. Lesser infection because not because of COVID, because of cold, flu, name it A, B, coughing, and so on. So there will be less medical bill. So health, wellness, and well-being are certainly one of the key areas that's coming up. We know we can change that. We can tweak around. Future of mobility, future energy. Smart is the new green thing, innovating to zero, new business model. Guys, you are in the generation Z. If you cannot have your mindset shift to here, you have difficulty to adjust in the current workplace now, right? Petronas, they are fighting this. They are consulting UTP on smart city, circular economy. They are looking into that, guys. Civil engineers are good in circular economy. You may have done some form of that. Intelligent building, smart building, right? Green building, GB, is part and parcel of that, but it's only one part of it. There are many parts of circular economy. So these are the trend we are moving on. As a civil engineer, you are a big, major parcel of that trend that you are looking into. Yeah. Other example, I know our associate professor, Dr. Noor Hisham, he is looking into monitoring the slope using fiber optic, monitor the tunnel using fiber optic. These are a future way forward, right, in assessing the structural health condition for tunnel, for slopes, for geotechnical use, for pipelines, and so on. It's funny, because in the past, Petronas, they use a pickup truck to drive along the way, check the pipeline. 500 kilometers, you drive 500 kilometers. This is something that is not right anymore. Today, they're using drone to fly. That's it. And it's far more cheaper than hiring manpower. They can program the drone to follow the coordinates. They can come back with a conditional report. That's it. They're settled on that. And this is the drone is about technology, right? That's not part and parcel of you and me as civil engineer. But what is the technology? Where are the gas pipeline? Is it broken? Has the ground been shifted? Are the foundation having any issues? Do we have a failure on the slope that will affect, or it's going to fail that will affect the pipeline? This is part and parcel of it. Next slide, Hasya. Right, I think the earlier speaker has talked about that. I just want to focus on that. I'm talking about I 4.0 today. Malaysia is quite high in I 4.0, but everybody is grasping. It's funny, when the first I 4.0 came out, everybody say they are the champion in I 4.0. When I ask them what project did you do, we haven't started on a project. So UTP has started on a lot of these I 4.0 projects today. We can do a smart monitoring of the pipelines, for example, right? We don't need pigging anymore, for example. We are going to pilot this in a very big way this year. And it's actually working together. Even civil engineering department get involved because it's a pipeline thing. And we are looking at how the impact inside of the pipeline just by looking at the conditional and the data that come out from it. Right, big data is the way forward. I think that's why in our curriculum today we have embedded big data. You need to understand how big data is. And normally, what you can do, you can Google. Google is a big intrusion of a big data in your life, right? Your Google, when you Google certain things, it have different value than mine. I look at different things, and you look at different things. So they keep track of what you're doing through artificial intelligence. Eventually, they will be able to predict you with 90% accuracy. What are the things that you like to look at? I like to look at cars, so they send me information about BMWs all the time, right? How do they know that? Because they see my patterns. So these are things that we have taken advantage. Petronas has a lot of data. They don't use much of it. So with our guys, we put the data together, right? In the past, we only have Met-Ocean data. We have 50 years Met-Ocean data. So what? But even with that, we can do a lot of things. We have made some discoveries as well, right? We have changed some of the spectrum of the ocean, and we have done a lot of that. But at the same time, there are other data that is coming available to us. Our IT department, together with our engineering department, can predict within 2 hours when the machine is going to fail. That's amazing. In the past, we wait till the machine fail, right? Or we hear some sound, get it. Oh, it's going to fail. But this time around, by using big data, by using the conditional assessment, it depends on various parameters. Eventually, we're able to forecast the failure accurately. This is the future, guys. No longer, if you want to become an inspection engineer, don't waste your time. You can become inspection engineer by using digitalization. Yes, you can specialize in that. But as a conventional inspector to inspect structural failure, that's it. This is the way of the past. The way of the future will not do that. So this will impact the overall social economic industry for the government, individual, and now we are going 5G, guys. Right? We are moving to 5G, so you will expect this thing will take place even more. It's kind of funny, but that's a fact. 50% of the world population don't have access to Wi-Fi, but the world is rapidly moving in that area. So you are fortunate in that sense. Next slide. So when you look at, these are the 4 key areas in oil and gas, right? You can be part and parcel of this if you're civil engineers. Number 1, exploration, find oil and gas more quickly. This is one of the way they have looked at that. I will share with you on that. Yeah, you can speed up overall time. I have, when I first saw our CSI, Center for Seismic Imaging, I told them, you must look at AI one day to predict where the oil reserve is going to be. You cannot be plotting based on the data logger you have obtained. It's not going to be the way of the future. That is going to be laborious. And sure enough, this thing is moving in that direction today, right? If you don't, you're going to die. So that's the first part. Second part, you extend the lives of oil and gas field because you have enough data. You can integrate the oil and gas production operation across the entire field to support enhanced recovery method. So actually, it's a combination of CFD, yeah, CFD, computational fluid mechanics, and then those software with those data that you obtain, you can actually enhance the life of the oil and gas field more accurately rather than by guessing. Third one, asset management. You can maximize return on your asset. Civil engineer has this problem. Every time you go and look at old building, you look at them and say, guys, I want to have as-built building. You know what they tell you? Oh, go to hell. We don't have that. We are thrown that away. So you don't have as-built building. I have done some forensic work that I don't have as-built building. What I have to do, I go to the field and measure it myself. Okay? So this is a rather big waste of time because I charge them. When I do that, I charge them for putting me on the site, putting me to go through all this crap that I have to do and measure. So with asset management, you can talk about reduced planned and unplanned asset shutdown. This is in particular when you talk about turnaround in oil and gas, right? You need to have good data. So with that data, we tweak into our program. We will know when the plant can be shut down and then move up again and then back online again quickly, because in oil and gas, breaking down is a very bad thing to do. So the best you can do for maintenance is when you do a turnaround analysis. Yeah, this is something that is interesting. Workforce collaboration, share knowledge across the organization. One of the things that you will notice that will hit you, the first thing that will hit you when you go to the workplace today, you will find that you are no longer a pure civil engineer. You are working with other people from other fields. And oil and gas is much more particular about this. They have people from the IT, people from mechanical, people from electrical, people from instrumentation, people from health and safety, for example. So they have to do a workforce collaboration. Yeah, you have seen these movies, yeah, where they have a major fire in the semi-sub drilling rigs, right, in the Gulf of Mexico. I think all of you have seen that movie, yeah. And you will see that before they went out, they have a tagging system. They know who went out to the offshore, who came back, right? In the Southeast Asia, I think sometimes if you disappear, nobody knows. So this is, we're still backward in that sense. We didn't quite digitize the whole thing, The whole system is not purely digitized where, you don't need to write down. I think right? I think COVID, some of the shop, you don't bring your handphone, you have to write down your name. This is a very bad way of doing business, actually, right? To track back, you have to go back every single line and see, like that. But if you have a digital system, you can track down who are the culprit that came in here and who has been infected with COVID, for example. So same thing with the oil and gas. When we talk about workforce collaboration, yeah. Next slide, Hasya. So I think as I move forward from here, smarter exploration. I think Repsol, they changed their name since then. It's breaking new ground. They are talking about accuracy of this sea oil exploration by reducing by 85% the time required to run the highly accurate and compute intensive seismic algorithm. So it's all about algorithm. You control the algorithm, not IT guys, right? IT guys will give you a platform. That's about it. Next one, Hasia. Okay, the other one is smarter production. You are using predictive maintenance equipment failures. You know, in the past, right, it's funny. Your professor will always screw you, when you talk about empirical formula, right? They say, if you can get the accurate formula, use the accurate formula. Forget about empirical formula. But you know what? Today, when talk about predictive maintenance, it's all empirical formulas. There's no exact formula anymore. As you add in the variables, it gets more and more accurate. But who is going to analyze those variables? You cannot use a hand to do that, but you can use a digital technology to do that easily. Yeah. Those days when I was analyzing data for my PhD in 1986, when I finished, I noted that the program that I used, I hit a return, I go back home, I come back 2.5 days later to get my output. That's how slow. That was IBM, guys. IBM. And these are Cray computer. Cray computer are responsible to put space shuttle into the orbit, but they are still slow. Today, you can do the same thing in a laptop. Amazing. But that's why I'm saying that this empirical formula thing on predictive maintenance is something that we have to look at very seriously now. Okay, there is a fundamental involved in that, but we do not have a clear demarcation what that fundamental stand for, right? So the formula, a lot of this formula will no longer be accurate in at the end of the day when we talk about predictive analysis. Yeah, next slide. And then smarter asset management. If you ask people, like I said, where are the asset, what are the parameters in the asset, a lot of times they don't have that. They have that, but in the analog format. So they have to digitize this. So one of the things that people has been engaging students to do is to digitize their data. So this itself is a very big business, but as it's a low-end business, they don't pay you much. All you do is just key in the data into the computer. It can be computed and they can be analyzed by using digitized method of doing that. So this is something that has been ongoing at the moment. And I think there are more and more efficiency. You will see that in the future as far as asset management is concerned, right? So project management, construction management, they'll tend to get easier and easier, right? Beams, for example, right? Beams are actually generated from oil and gas industry. They look at how the pipeline don't clash with each other on top of vessels, for example, on top of a production plant. They have done that a long time ago, but they don't call it beams, right? Unfortunately for them. But today, civil engineer know it's beam. So we use it for building at the same time. Next one. Then these are structural health monitoring. This is our project in civil engineering department. We have done some pilot study. I'll give you the monopod, the center one. That's interesting, That platform, if you go there, you won't last 1 hour, you will vomit, That thing moves, it vibrates, It's the period of vibration will affect you. It's not about failure, it's not. They will just keep on moving because just like a column standing, right? And they have mooring lines. So all it does is just move. You can feel it, What happened is they feel like there's something wrong with the platform. So we went there, we do a structural health monitoring. We have the algorithm. And eventually we found out that one of their riser was loosed, right? Was turned loose from the platform, actually welded, and it solved the problem. That's it. Yeah. It will take inspector a long time just to find out about that. So since then, this technology, structural health monitoring, has been done by different faculty members in civil engineering. Dr. Hisham focused in the onshore. Our other offshore team focused on the offshore in the water side, and so on. So these are something that, you use technology. You heard the word digital twin. What you see over there and what you see over here, they are similar. So this is another area that has been fully developed now. And actually going for startup, UTB is going to have the first startup in terms of structural health monitoring. Yeah, so we are the pioneer in this area, and we will continue to do that. So if you can even specialize in this area, because this area is fit for purpose. It's not that you learn something in general, you have it. No, different platform, 3-legged platform, 4-legged platform, 6-legged platform, you know, and they have different behaviors because they have different structural configurations. Okay, this is interesting because there's so much thing that can be done. We haven't even correlate the result that we get to actually was the structure optimized in the design in the first place, right? Because, you know, Malaysian engineers are very conservative in their design. Yeah. So being conservative in the design, they tend to add more steel. If you have heard, people have always said Malaysian platform has some of the heaviest platform, right, per ton. In terms of their production, because we have designed our platform to last for actually, our some platform has last 30 years, although the lifespan is only for 15 years of oil production. So this is what I call over design. But we haven't gone to that stage. So that's another opportunity that you can look at on how you optimize the design by looking at the current structural health monitoring system, yeah, and the result that you get. Next slide, Asia. So as you can see, as Hasya is changing the slide here, and we'll look at the next one. Boleh, Hasya? It's not moving, eh?
I'm not moving. Okay. Again.
Right. And then the other one is about smarter workforce collaboration. You're talking about reduction in injuries. Example, right? We are doing, you know, the virtual reality, and then we are training people on the offshore platform. By putting on the virtual reality, they can see the actual platform. In the past, you attend the class, they tell you can do this, you don't do this, you don't do that, you can do this, you cannot do that, right? But today, when you wear the glasses, it'll tell you the real life platform, what you can do and what you cannot do. Okay, similar technology as an engineer we are putting in together for Tabung Haji, for the pilgrims, for example, right? In the past, they have a course. You know, I think you have seen this, right? They have small Kaaba, they ask people to tawaf, they share with them, this is what you do, you know, when you go there. It's kind of funny, right? These are physical process. If you put you can see the real Kaaba. You can actually digitize the whole frame of Kaaba and what is around it, you know, Marwa, Safa, you know, and then you can know where the Aziz Gate is, you know, you can show everything in VR. So when people go over there, they're smarter, right? It's not like a 2D pictures you show them, this is how it looks like, or this is how it looks like, and so on. So these are some of the smarter workforce collaboration involved in using that. Oil and gas are using that in a very big way now. Yeah, every oil and gas outfit is actually at the beginning phase. Don't think that they are already very advanced in digitalization. No, they just started, and the most they have done it 2 years ago. Okay, Petronas started last year, some of the thing, and I think we have been helping them. At the same time, I think they also outsource to some of the other bigger digitalization companies do that. We are more as an engineer, we look at the algorithm on what needs to be done. Yeah. Any more slides, Hasya?
2 more, Prof.
Okay. Right. So these are some of the companies innovating cutting edge technology. Some of the, I think by looking at that, you see a lot of the common name up there, which I don't need to introduce to you anymore, right? You know that. I think that's about it lah. I think. Hasya, ada lagi? Tak ada kan? All right. So these are the fast-changing innovation and breakthrough, render existing business model obsolete. You can see the biggest one is wearables. Wearables will be the thing of the future. Blockchain. I am a personal proponent of blockchain, right? As an engineer, this is how I think. You also as an engineer, you should think like this because digitalization is going to be part and parcel of your life. I may not be the first one, but I think in this country, perhaps I'm the first one who are actively promoting blockchain in halal industry. How does a freaking civil engineer like myself know this? It's very simple, right? Civil engineers, we do project management. Project management is about managing the data well, know the sequence of things that has happened at any point in time for the project. When you apply that in halal industry, it works the same way. It's about data keeping, and how do you make sure data keeping is good? Using blockchain technology, because every person should endorse and sign off every time we agree on certain things. Similar with project management, guys. You get an architect to sign off, you get an engineer to sign off, you get an owner to sign off, and then you issue a variation order to the contractors. Please do this. That's it, right? So these are the thing of the future. But I'm going to be caution you one thing, right? This thing is going to hit a saturation point. Blockchain, cybersecurity, cryptocurrency, you name it. By 2025, it's going to be saturated. The technology cannot go much further anymore. So whatever we have today, we have to work pretty hard, pretty fast for the next 5 years. If you are not, you are late. You are too late. Any businesses that doesn't succumb to digitalization, you are sure set to fail. Online business is big. In pandemic, it has been proven to be bigger. Yeah, but it has already been there. Lazada has been there before pandemic. Shopee has been there before pandemic. But this is just a platform, and people are making money from platform. How silly we are for not thinking like this, right? So these are how I see the fast-changing innovation in engineering as well. How do we keep track of things that we are doing as an engineers, civil engineer? I'm not here to teach you the subject matter. I'm just trying to tell you that how you should relate back digitalization and how it will affect your career in the future, and what are the things that you need to be hands-on, right? Here on. Ada kita, Asia? Okay. So I think these are very wide subject. I have a lot of case study example, but I think I cannot do it within 1 hour to share with you. All I can tell you today is take comfort of the fact that the construction industry is moving towards digitalization as well. A lot of things are very much automated today. So we hope that you all will start to look at reskilling yourself if you do not have the skill, upskilling yourself. If you upskilling is higher than the reskilling. Upskilling means you totally don't have that skill, right? So people like myself, I have to reskill and upskill on digitalization. Yeah. Writing program, we can write that as an engineer, but so what? Writing program just getting a solution, but it's not digitalization. It's a big difference. So take note what we are talking here. Being able to operate software is not digitally smart. Yeah. Just is being able to operate software. Yeah. So this is what I have. So thank you very much. I hope this is informative enough for you all for this evening. Thank you.
Okay. Thank you very much to Associate Professor IR Dr. Muhammad Shahil Liu for giving such an informative and interesting talk. So we would like to open the floor for inquiries, if any. Is there any question?
Just a little correction. Prof. IR Dr. Shahil Liu is not associated, Prof. Thank you.
Okay. It's okay. Thank you.
Okay. Okay, I'm so sorry. My mistake.
It's okay. No problem. Yeah.
So, Professor, this is one question from Arina. Okay. So, the question is, Prof, may I know what is your opinion on the potential wave energy, energy from ocean wave in Malaysia? There are several wave energy farms in Europe using offshore, which harvest energy from the ocean wave. I have yet to hear more discussion about consideration of ocean waves as a potential renewable energy, and I wonder why.
Good question. I have the answer though. All right, if you look at our South China Sea, although it is scary, right? During the monsoon season, you can see the wave is kind of big. The cloud is very cloudy, it's very fierce looking, right? Very stormy. But in reality, even under a stormy condition, under monsoon condition, our wave height is very small. Our wave height is very small, and our wave energy, definitely, when you look at the spectrum, is also very small. Okay, if you look at in the European country, North Sea, you're talking about 18 meter height, for example, and they can really achieve that, right? Our side here, we're looking about 5 meter. Okay, so that's a big difference, 3 times. that different. You go to Brazil, deep water, they are talking about huge wave. And the period of wave is also longer, right? So therefore, as a result of that, same thing with wind. We don't have a very heavy wind in Malaysia. I remember telling Petronas this when they tried to pilot a wind study. I said, it's not going to work, even if you look at low speed wind energy, because we just don't have enough the kind of wind that we look at in Denmark, in the North Sea, where the wind is very, very strong. So this is where we do not have that kind of advantage. People don't talk about that anymore in Malaysia, actually. They have abandoned the subject. Okay, good question, but that's a good question though. The potential is there, but you need to have the right condition to do that.
Okay, Professor, there is one more question at here.
All right.
From Zhen Shen Liu. So the question is, as the civil engineering sector is moving towards digitization, and how it can be imagined that more job opportunities will transfer towards people from IT background. As a civil engineer, how can we increase our competitiveness?
Oh, that's a very tough question. It's like Viva question, huh? For
Yes.
for your FYP, yeah. Okay. As a civil engineering student, you look at, there are a lot of things that we do in a very traditional way. Civil engineering is a very traditional profession. We have to accept that. We are very conservative people. We have come through 3,000 years ago, building all sort of things, including the pyramid. And today, we are looking at, the first earliest form of digitalization is actually our CAD, AutoCAD. Yeah, people don't realize that the AutoCAD has made our life very easy. Our drafting, you look at our draftsmen today, they cannot write in pen and pencil anymore. They cannot do that. And their handwriting will not be looking good. In the old days, draftsmen makes a lot of money actually. But since that is gone, so we have moved on to AutoCAD. Then from AutoCAD, we are actually looking at software now. Last time we used approximate method in analysis, then we use software. With software, we have an accurate result, right? We have good result, then we can go on from there. That is actually a form of digitalization, but that is more of knowledge acquisition, and that's how you become more efficient. So now people are integrating all this together, right? I just shared with you just now structural health monitoring. To have the knowledge in structural health monitoring, number one, you must have a strong structural background. No question about it. That one is very important. Number two, you must be able to operate a software. Okay, so this one should be given, meaning these two you should acquire from the university by the time you get out. Third one is about digitalization, how you put this thing together from the data that you obtain from your structure, arising from your sensor that you put on your column, your diagonal bracing member, your beam, and what does it tells you actually. So this is something that your mindset must migrate into so that eventually you can do something in relation to digitalization. I hope that answered the question. So I think that part you have to develop. We developed that also through the years, and it takes a short while because normally you guys are smart. All the things is smart. Only you can play the handphone very well, software very well. So it's actually quite peanuts to do that at the end of the day. Okay.
Okay, Doctor. Okay, Professor. Okay, thank you very much to Associate Professor IR, Dr. Muhammad Shahil Liu, for giving such an informative and interesting talk.
Thank you.
So, with that, we finally come to the end part of today's forum. I will pass it back to the MC for photo session.
No teh tarik, ya?
No, Prof.
virtual teh tarik.
Thank you to the moderator, to the honorable guests, UTP civil lecturer and staff, as well as the committee member. Please open your camera for a photo session. The time now is 4:14 p.m. and we will allow until 4:16 for our participants to turn on their cameras. In the meantime, for the media department, please be prepared for the photo session and be reminded to count from 1 to 3 before taking the photo.
right. So the photo will be taken under the count of 3, 2, 1, smile. Okay, let me take for one more. 3, 2, 1, smile. All right, thank you for your cooperation.
Thank you.
All right, welcome.
Before ending the forum today, I would like to express our gratitude and thankfulness to the speakers for presenting such an informative and exciting forum. I would also like to thank the participants for spending their time and evening with us. We hope that all the knowledge gathered this evening will benefit you in the future and will drive you continue your career as a civil engineer. For your information, we will be conducting several competitions during this Civil Week. Do join us for poster, video and AutoCAD competition. Details for the competition may be found at our official Instagram page at UCT_official and at ICESC.UTP. The registration will close on the 5th of March 2021 for the AutoCAD competition and on the 7th of March 2021 for the poster and video competition. As has been prior informed to all the participants, there will be a quiz at the end of this forum, and we will award 3 students with the highest point to win the prize from us. In order to access and take part in the quiz, you are required to remain in the YouTube live session. We will conduct the Kahoot quiz via YouTube live stream. Thank you and have a good day. Stay safe.
Thank you very much, Prof. Shahir.
Thank you. Thank you.
Thank you. We appreciate your presence with us today. It was a very formative information for all of us, lecturers and the students as well.
Thank you, Prof.
Thank you, Prof. And thank you to all the lecturer that has time to join us for today's session as well. Thank you.
Thank you, Anna. Thank you, UCT committee members. Thank you, ICE Student Charter committee member. We appreciate your effort. Well done. Thank you.
Thank you. Thank you.
For all the lecturers, for attendees, and all the participants. Thank you.
Thank you very much. So lecturers now can leave, right?
Yes.
Okay. Thank you,
Yes,
Anna.
yes.
Thank you.
Thank you, everyone.
Thank you, everyone.
Okay, Professor Basha. Have a nice day, Prof.
Thank you. Thank you. Thank you.
Thank you, everyone.
Well done, all. Thank you. Congratulations.
Good job, students. Thank you. Bye-bye.
Thank you. Thank you, Doctor.
Thank
Thank you, Doctor.
Thank you, Doctor.
Salam, you may start the next session.
Good evening, everyone. Thank you for showing your interest in joining our quiz session. This quiz session will be passed over to our informal MC, Lee Chi Yang. Chi Yang, please take the floor.
Thank you, Salam. I will take it from here. Good afternoon to all the participants. Welcome to Silver Big Quiz section. My name is Lee Chi Yang, and I will be the MC for this quiz section today. On behalf of UCT and ICE, we would like to give out our thanks to every single one of you that participate in the quiz. Today's quiz will be related to the forum that was given just now by IRS Gandhi Supia about the modular construction and manufacturing in IBS, and Professor IR Dr. Muhammad Shahid Liu about the transformation of oil and gas landscape, enabling digitalization. Before we start the quiz, I would like to explain on the rules and regulations for the quiz. First, the quiz will be done on Kahoot. Second, only one user per game is allowed. Third, all the participants must use their real names when they participate in the quiz. Any inappropriate names would be immediately counted as disqualified. Fourth, each participant will be asked 15 questions, which is 7 questions from IBS and 8 questions from future engineering in digital age. Fifth, all the participants will give 20 seconds for each question. Sixth, if the participants are unable to answer the following question in time, then the system will proceed to the next question. 7, there will be 3 prizes for the first, second, and third place to be won. Without further ado, I will begin with out the code for the quiz. So the code of the quiz is 5766163. Logging into the Kahoot through Google Chrome or browser and enter the game pin 5766163 to enter this quiz.
Dear students, please be reminded that you will need to use your real names and not emojis or any inappropriate names when joining the Kahoot quiz. Thank you.
Hafiz, Zudin, stop sharing and share back. The screen is black now.
Boleh nampak ke?
Boleh. Okay, Bidin, clear.
Hafiz, dekat ikon sound tu boleh tinggikan tak? Nampak tak ikon volume tu? Yang atas tu, yang tak ada bunyi.
Ke sebab tak share include video sekali?
Yes, you should include the video sound.
Try je. Hafiz, no need lah, just start now.
Ya.
Okay, nice. Dah boleh dengar. Okay.
Okay. If everyone ready, we can start our quiz now.
Yeah, Xiang can start now.
All the participants, please be ready. The quiz will be starting now.
Then dah boleh start dah.
The first question of the quiz. What is Next question. What is the main advantage of using IDF? Thank you. What does MS stand What is the object? Number 7 question. We and back. Number 8 question. What as much as question and do that?
Din, stop freeze, stop freeze, stop freeze, stop freeze, stop freeze, stop freeze, stop freeze. Ya, jangan tekan next, jangan tekan next, jangan tekan next.
Okay.
Jangan tekan next eh. Proceed. Proceed.
Proceed.
Yeah, proceed.
Why there is a digitalization in oil and gas industry? Our last three questions. When was the Perpectives introduced to the industry regulation? Number 13 question. These are one of the four key areas within the oil and gas industry for digitalization application except for Question 14. The Senate now are part of the committee for our last question. Forum. Congratulations on getting the third and second place for the forum session goes to Diana. Well done for getting second. Finally, our first place goes to Ahmed. Congratulations on getting the first place for the forum and quiz section for Silver Week 2021. Before I end this session, I would like to thank and congratulate everyone for participating in the quiz. I wish everyone have a good day. Goodbye and stay safe.
Okay. For that, I would like to apologize for the inconvenience where there's the delay on the YouTube, and I think the quiz is a little bit unfair, so I would like to apologize for the delay and all. And the quiz seems like unfair, to be honest. So once again, I deeply apologize for any wrongdoing I did just now.
With that, we will end the forum session today. And we hope that all of you gain information from the forum that we have conducted today. For the winners, kindly take a screen capture of your podium and send it to any of our committees, or you can just drop it at our official email, which is uctcommittee@gmail.com. I repeat, uctcommittee@gmail.com. The media team, you may drop our email in the YouTube live chat so that our winners can email us their screenshot for verification. That's all from me. Thank you, everyone.
you.